Hi, this is Fatila Lohar, Assistant Professor, Department of Electronics and Communications at Engineering College, Delaware. E-lectures is prepared for RT syllabus, antenna and propagations for 6th semester EC student. In last lecture, we have discussed the transmission line model for microstrip antenna analysis method. In this lecture, we will discuss the cavity model of antenna. So, cavity model, basically the microstrip antenna is represented as a dielectric loaded cavities, and this cavity may be generate exhibit higher order resonance modes. Okay, and the normal fields within the dielectric substrate are easily analysis and accurately analysis between the page and the ground plane. And the electric field represented electric boundary is represented by the page and ground, and magnetic boundary is represented by the peripheral of the microstrip antenna. Basically, this is the approximate model, okay, which principle lead to reactive input impedance of 0 or infinite value of resonant, and it does not radiate any power. Basically, we assume it does not radiate any power. However, assuming that the actual field are approximate to those generated by such a model, the computed patterns, input impedance and resonance frequencies compare well with measurement. Compared to the transmission line model, the cavity model is higher accurate. Okay, there are the two methods for analysis of electric charge distributions on the page and ground. One is attractive and second is repulsive methods. Okay, the attractive mechanism between the corresponding opposite sides of the bottom of the page and the ground plane, which tend to maintain the charge concentration of the bottom of the page. The repulsive mechanism is between like charge on the bottom surface of the page, which tend to push some charge from bottom of the page around edges to its top surface. Basically, this positive charge is repulsed to this page charge, positive charge, and attractive nature to this negative charge. Similar thing for this negative charge. This is opposite charge reflected, and this charge is attractive. Okay. Field configuration is mode for TM. Okay. The dielectric material of the substrate is assumed to be truncated and not extend beyond the edges of the page. The vector potential must satisfy the homogeneous verifications. This is the homogeneous verifications, and the solution is given by this in x, y, and z directions. Okay, this is the rectangular microstrip page. This is represented as a cavity model. Now, where kx, ky, and kz are wave number along with x, y, and z direction respectively, this will be determined subject to boundary condition. The electric and magnetic field within the cavity are related to the vector potential Ax. So this is the electric field in x directions, electric field in y directions, electric in z direction, and this magnetic field in x directions, magnetic field in y direction, and magnetic field in z directions. So total field within the cavity is given by these equations. Okay. Now here AMP, this represents the amplitude coefficient of each MNP modes according to the wave number kx, ky and kz. Okay, so ky, kx, ky and kz are given by these equations. Okay, m and p represent the half wavelength numbers. Okay, half cycle field comparison along the xyz direction. Since the wave number kx, ky and kz are subject to the constant equations, so resonant frequency for cavity are given by these equations, where m and p is represent the mode numbers. Okay, now to determine the dominant mode with the lowest resonance, we need to examine the resonance frequency. The mode with lowest order resonance frequency is referred to the dominant modes. Placing the frequency in ascending order determine the order of the mode of the operation for all the acoustic antenna. H should be less than L or H should be less than W. If L greater than W and W greater than H, the mode with the lowest frequency, dominant mode, is the TM010 modes, whose resonance frequency is given by these equations, where V naught is the speed of the light in the free space. If in addition, if L greater than W and W greater than L by 2 and L by 2 greater than H, the next higher order mode is the TM001, whose resonance frequency is given by this equation. Okay. Now, if L greater than L by 2 and L by 2 greater than W and W greater than H, the second order mode is the TM2 mode instead of the TM001, whose resonance frequency is given by these equations. So, with these four pattern represent the number of mode pattern. Basically, this is field comparisons for rectangular magnetic page. This represent the TM011 mode. This represent TM001 mode. This represent the TM020 and this represent TM002 modes. Okay, so in this diagram TM010, you can see the electric field lines are, this is the electric field line. Okay, and this represent total length is approximate lambda by 2. So this represent the one wavelength lambda in L directions. So this represent, this portion is lambda by 4, this portion is lambda by 4, total lambda by 2. Okay, this is electric field representation in L directions. Electric field distribution in W direction. W direction is uniform, and electric field intensity decreases at minimum middle of the page and maximum at edge of the page. So in this portion the impedance is maximum, and in this portion impedance is minimum. The meaning of this, that the magnetic field is at this position is maximum and electric field at this position minimum. Similarly, in this portion magnetic field at this position is minimum and electric field is maximum. So this portion also is work as a short circuit between ground and page. Similarly, this is the TM001. So you can also say that this is the orthogonal modes. Basically, this is 90-degree shifted model. Okay, so this represents lambda by in W direction. Okay, this represents in W directions 001. This is lambda by, this is lambda by 4 and this is lambda by 4. Total is lambda by 2. Okay. Next is MTM20 020 means in L directions this is lambda by 4, this is lambda by 2, or this lambda by 4. So total 2 into lambda by 2. So we put 2 equal to 2 half wave lengths along the L directions. Similarly for the, this is in this person W directions, this represent lambda by 2, this portion represent lambda by 2 4, and this portion represent lambda by 4. So total 2 half wave length lambdas number. So we can analyze this cavity model in this type of the figure, and according to the electric field analysis we analyze the electric cavity models distribution and finding the which mode is dominated and which mode is higher order modes. So generally dominant mode is high accurate and provide high performance characteristic of the antenna, but higher order mode is maximum is generate high losses and antenna performance is low. So dominant mode is for initial antennas. Dominant mode is provide the good characteristic of the antenna.